Okay, we're going to talk about 1.5 angle relationships. So we already studied different types of angles, the way to classify them, acute, obtuse, right, and straight. And so now we're going to learn different types. These are special angle pairs. The first one we're going to study are adjacent angles. Adjacent means next to or beside. Like if your next door neighbor, their house is adjacent to yours. It's next door. So an adjacent angle, they're beside each other, but it's more specific than that. They have to have a common vertex and a common side, but no interior points. So basically what that means is that they share a side and they can't overlap. So like angle 1 and angle 2 are beside each other. They share this side right there, but they don't overlap. Those are adjacent. Same thing here. But if we're talking about angle 3 and then ABC, well, ABC is all of this. You can see those overlap. So those are not adjacent. Here we have angle 3 and angle ABC, but they're not actually beside each other. They need to share a common side, remember? So that's non-adjacent as well. So that's the first type, adjacent. The second type is linear pair, and that's a pair that forms a line. So it's a pair that forms a line. They're adjacent angles, so they're still beside each other, and opposite rays, they form a line. So you can see angle 1 and angle 2, they're a pair, and they form a line. They're beside each other, they're a pair, but they don't form a line. Vertical angles. Vertical angles, I like to think of V's for vertical. It's like I have two V's. Vertical angles are non-adjacent, so they're not beside each other. They're actually across from each other. So I have two intersecting lines here, and angle 1 and angle 2 are vertical. Angle 3 and angle 4 are vertical. So they're across from each other. They don't have to be just vertical, they can be horizontal. We'll also learn later that vertical angles are always congruent. Okay, so you can kind of tell my angle 1 and angle 2 are the same, and 3 and 4 are the same. Here, this angle is not vertical to this one because there's a line, but that is not a line. So if it were like this, that would be vertical. But when it shoots off separately, it's not. Okay, so now let's practice some of these. Remember a linear pair, and fill this in your own words, but a linear pair, two angles, not more, that make a line. Okay, well, over here in this picture, I have this angle and this angle, but together they don't make a line. But remember, you can always skip over some stuff. So if I look at this line right here, I can split up and I can use this angle and that angle. Sure, I have Q there, but I don't have to use it. So I would name this angle UIP and PIR, and together all of that makes a line. It's two angles that make a line, so it's a linear pair and they're adjacent. Now, there's several other options, and we could do something like this and this. There are several options there. As far as two acute vertical angles, remember vertical angles butt up against each other, they're across from each other. They make that B. So if I said PIQ, the vertical angle to that would be TIS. You could also do UIT and QIR. You could also do UIP and RIS. So any of those that are across from each other. Okay, I would like for you to pause the video, answer these questions, and then start it back and check your work. You can see how important it is to be able to name angles correctly. So two adjacent angles whose sum is less than 90, you have two options, either are two red angles or are two green. When it comes, and then you can check the way you name those. Remember, they could be named backwards, obviously. Name two acute vertical angles. So you have two different options for that because they're acute. This one doesn't work, but 95 and 95, those are vertical. But you have CAD and NAF, which are the orange angles, or you have our two 30-degree angles. Either one of those worked. Okay, so here's that definition. The vertical angles are congruent, always. Okay? So you should have two sets. This should be congruent, and this should be congruent. And then here are words that are not new to you. Complementary. It has to be two angles, and they add up to 90. Supplementary, two angles that add up to 180. Okay, remember, it's a compliment if it's like, oh, you look so cute. You're so cute and little. So that's a compliment. It's like the smaller angle. Oh, it's so cute and small, like a little puppy. It's a compliment. The easier way, I think, to remember it is in the alphabet, C comes before S, and 90 comes before 180. Okay, but make sure you can remember the difference in those two. They can be beside each other. They don't have to be beside each other. So you might know they add up to 90 because of the box, or you would know because of the degree. For supplementary, they could add up to 180, or they add up to a line, so you know 180. And then this says that linear pairs are supplementary. Well, we already talked about that, right? Because linear pairs form a line, and a line has 180 degrees. So now we're going to do two supplementary angles with some algebra here. So it says find the measure of two supplementary angles if the measure of, that should be an angle, is 6 times less than 5 times the measure of the other angle. Okay, so first of all, this relates the measure of the two angles that are supplementary. It says that in the problem that they're supplementary, which means they equal 180 degrees. So we're just going to draw two angles. We don't really know what they look like. You can draw any two angles, but please draw it up. It helps a lot. And then always call one x. Okay, so draw two angles and always start with 1x. Now I can label the other angle. So it says 6 less than 5 times the measure of the other angle. Well, the other angle is x, so this is going to be 6 less than 5 times the other angle. Now I know these are supplementary, so they're going to add up to 180. So A and B is going to add up to 180, so I have A and B. And together, that is 180. We said we had A and B. A lot of times we can get the 5x minus 6, but you'll forget to add in this extra angle, which is why it's really, really important that you draw both of them to work that out. So I'm working out the algebra for you, and x is 31, and it says find the measure of two supplementary angles. I don't have two answers yet, so I know I'm not done. If I plug back in, x is 31, so this angle is 31 degrees. That's this answer. For here, I would do 5 times 31 minus 6, which is 149. And the great thing about these problems is you can check your work. 31 plus 149 equals 180. Check. That means it turned out right because it said they were supplementary. That was the whole. So as long as that works, you know you did it right. I would like for you to work this one and then make sure you draw out the picture and everything. Work this one and then come back and check. Okay, so these two are complementary, so they equal 90. And again, it doesn't really matter what your angles look like. It's just to help you. So one is x, and one was 6 less than 5 times the measure of the other, which is 5x minus 6. Now, that happened to be the same algebraic expression as the one above. That will not always be true. Okay? And then I'm going to add these up this time to 90, so make sure and read carefully. Solve, and I get x is 16. I plug into the other one and get 74. Perpendicular lines, probably not a new word to you. Perpendicular lines are two lines that intersect to form a right angle. But if this is a line, and that's 180, and this is 90, then this is also 90. And if that's 90, then this is 90. If that's 90, this is 90. So when two perpendicular lines intersect, we put a box there, but all four of these, all of them are right angles. Okay? And that also means they're all congruent. And there's a certain symbol. Of course, we have our right angle symbol box, but this is the symbol. It's like an upside down T to say these two lines are perpendicular. So find x and y so that KO and HM are perpendicular. Well, let's find KO and HM first. So we have KO and HM, and if these are perpendicular, so KO is perpendicular to that symbol, then that means that they form a right angle. Here, 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 here. Now I'm specifically concerned with finding X and Y so that I know all of these angles form 90. So we're going to start with KJH over here, KJH, which is this one. So I know KJH equals 90 degrees. And so I have these two small parts. One is 9x and one is 3x plus 6. So I'm adding up the two parts to the whole. So the measure of KJH we know is 90. And that's going to be equal to 12x plus 6. Okay, so that's part of my answer. So I'd find x and y. Well, we found x. Now we need to find y. And we're going to be using this right angle. So we know 3y plus 6 equals 90. And why we know these are 90 is because they're perpendicular. And perpendicular forms right angles. And so y is 28. And there are your answers. I would like for you to work this, check your progress, or pause the video, work it, and then come back and check it. So if these two lines are perpendicular, they form a right angle. So 4x plus 5x equals 90, solve, and x is 10. Okay, so this is just talking about diagrams when you're looking at a picture. If you see that points are on the same plane or same line, they're collinear. You can always assume, like, if they go through a point, that they intersect there. And you can assume what's on the interior or exterior. You can assume if they're adjacent, a linear pair, all of that. But what you can't assume is that the lines are perpendicular, not unless it tells you or gives you a right angle. And you can never assume any segments or angles are congruent unless it tells you. Okay, that's the only way we know, or if we calculate it. So it says, determine whether the following statements can be justified from the figure. Do we know that VYT is a right angle? Well, we do know that VY and TX here are perpendicular. We know that because there's a right angle there. If there's a right angle there, then that means there's a right angle there. So yes, we can know that. Do we know that TYW, so this big angle here, and TYU are supplementary? Yes, together they form a line, so they are supplementary. Do we know that VYW and TYS are adjacent? No, they do not share a common side, so they are not adjacent. I would like for you to work the check your progress last bit, pause it, work it, and then come back and check it. You all know, but let's look at y. XAY, it sure looks like a right angle, but it doesn't tell me it's 90, and there's no perpendicular, so I don't know. On the second one, it gives me this angle and UAY this angle, and it wants to know if these are complementary. No, what are they? They're supplementary. But we could assume that if it said supplementary, it'd be yes. And then UAX, so this angle right here, is it adjacent to UXA? No, they do share a common side, but they don't share a common vertex here. So we looked at an example like that. They have to share a side, but also a vertex. Awesome job. That was section 1.5.